I hope you've been following along. Try to answer this question. When will the boat be directly east of the lighthouse? So right here I've given you the vector equation for the path of the boat, and I also given you the parametric equation. So hit the pause button and try to solve this question. Now I hope you did hit the pause button and solved it. So what you're looking for is, as this boat travels along this directional vector, right here, you're trying to find when the boat will be directly east of the lighthouse. Here's our solution. Now the reason I crossed out the X was because I don't know what the distance is between the lighthouse and the boat, so X is I don't know. I do know that the boat is neither north or south of the lighthouse, it's directly east of it, so Y is 0. Substitute for Y, use your subtraction property of equality, simplify, use your division property of equality, and you end up with 7 equals to T. Or in 7 hours, the boat will be east of the lighthouse. I hope you got the right answer, and let's move on. To recap, parallel vectors. If vector A is parallel to vector B, and remember we write it like this, A parallel to B, then there exists some constant, there is some number such that vector A times a number is equal to vector B, or I could write it the other way around, vector A is equal to some number times vector B. Now, let's just look at a few examples since we already went over this in class. Example, is vector A parallel to vector B? And example B, is vector A parallel to vector C? Here I have the component form of vector A, here's the component form of vector B, and here's the component form of vector C. Let's first start off with A. So if A was parallel to vector B, then there will exist some number such that vector A will equal vector B. What we want to know is, does this equal? So I have a little question mark there. So the first thing I do is I write the vectors in component form. Vector A is 4, negative 2, and vector B is negative 8, negative 4. Using the distributive property, I distribute the k to the 4 and the k to the negative 2. And that gives me the equation, the vector equation, 4k minus 2k is equal to negative 8 minus 4. Let me get a little bit more room here. What I do next is I'm going to separate the x component. The 4k is equal to negative 8, and I'm going to separate the y component. The 2k is equal to negative 4. First, I'm going to solve for the x component. I divide both sides by 4, and that gives me k equals to negative 2. Now I'm going to solve for the y component. I divide both sides by negative 2, and that gives me k equals to 2. Note that negative 2 does not equal to 2. What that means is that there does not exist a k to make one vector equal the other. Therefore, A is not parallel to B. Moving on, I will now try to solve for vector C. Let me just put a little line in between these two to separate my work. Let me extend the page a little and carry this line further. Well, the next thing I want to find is vector A parallel to vector C. Well, the first thing I do is I want to know if there exists a k such that vector A equals to C, vector C. So I write vector A and C in component form, and I distribute my k to my both x and y components, which gives me 4k negative 2k is equal to negative 8 thirds 4 thirds. Now what I'm going to do next is I'm going to separate it between the x component and the y component and give myself a little bit more room here. And I separated, the x component is here, the y component is there, x and y components. Multiply both sides by a fourth to get rid of the 4. Simplify, that gives me k is equal to negative 2 thirds. Now I'm going to work with my y components. Multiply both sides by negative a half. Simplify, that gives me k equals to negative 2 over 3. In case you're asking, cross multiply. 2 goes into 4 2 times. 2 times negative 1 is negative 2. Right here, 4 cancels out. 4 cancels out right here, negative 2. Notice in this problem, negative 2/3 does equal to negative 2/3, and therefore vector A is parallel to vector C. I'm going to stop right here. In the next video, we will discuss the differences between a velocity vector versus a directional vector. So please watch the next video.